Okay, geometry, lesson 10, module 1. Right now we are going to begin lesson 10, and the title of the lesson is Unknown Angle Proofs, and we're going to have to perform these proofs with some constructions that we're going to make. And we're going to start with the classwork opening exercise. And it talks about these two figures over here on the right. And it first of all gives you that AB, right here, AB is parallel to DE. My lines aren't very straight, but they're parallel. And then BC is parallel to EF. So we need to construct these lines going further out in this proof. It says prove that B is equal to E. And the hint was to extend BC, which I did in blue, and extend ED, which I did in red, and something should begin to appear. For example, we should note that since the two red lines are parallel, this angle here and this angle here are congruent. That means B is congruent to, let's call this angle Z. Just name it Z. And we also note that for the same reason, E is congruent to Z. And so that leaves us with the sort of an easy proof. And the proof lies in first, I'm going to write my two columns, statement, and my reasons. And number one, I'm always going to put the given. So the given is AB parallel to DE and BC parallel to EF. And the reason, well, the reason is simple. It's given to us. So that's the first statement. The second statement is angle B is congruent to angle Z. And the reason, alternate interior angles. The third statement, angle Z is congruent to angle E. Same reason, alternate interior angles. And then finally, the fourth and final statement, we've proven that angle B is congruent to angle E. And this reason is something called the transitive property, which basically means the transitive property, which basically it's related to substitution. So we're going to talk more about what that means, transitive, but it's more or less when you get that situation, if B is equal to Z and E is equal to Z, well, B is equal to E, transitive property. So that concludes our first proof. In the previous lesson, you used deductive reasoning. Deductive reasoning. It's important. This is a key idea. With labeled diagrams to prove specific conjunctions. What is different about the proof above? Well, the difference is you had to draw and extend some segments, lines, and rays. And we've seen that, and they're called auxiliary lines. Well, this is frequently used in demonstrating steps in deductive reasoning process. Once BC and ED were extended, it was a relatively easy proof. Let's look at the next example. In this next diagram, there are at least two possibilities for auxiliary lines. Can you spot them? Pause for a second and think about that. Can you spot two different possibilities for auxiliary lines to help us prove Z is equal to X plus Y? Okay, let's see where they're at. Oops. Here's one possibility. This is in the book. This is in the next page. Here's one possibility, and they go through and they start the given, they state the given, they state what they're going to prove, and then they extend the transversal line down with the dotted line here. So they're extending this line right here. You can see that dotted. And you might be asking, well, what does that do? In other words, what do you know about V and X? What do we know about V and X? Well, you should be saying, I know V and X are corresponding angles. That means they're equal. So that's one of the questions it's asking you. And about W and Y, what do we know about W and Y? Well, W and Y, they're equal because they're vertical angles. How does this help? Well, take a look at the proof. I'm going to show you the proof for this particular one. And again, those two observations allow us to actually prove that Z is equal to X plus Y. So in your workbook now, you could fill the proof in for this first diagram, the first possibility. So take a look at this proof given the auxiliary line coming down for the transversal. Another possibility appears in the same diagram. Take a look at what's different. So here we have the same diagram, except now they chose the auxiliary line to be here, instead of coming here. So what do you know about V and X? And then it's asking you questions. V and X. Well, we know V is congruent to X, corresponding angles. How about W and Y? W and Y, same reasons. W and Y are equal, corresponding angles. Write a proof using the auxiliary segment drawn in the diagram. Notice how this proof differs from the original one. And so here we go with the proof. So I'm going to back out of this. I'm going to go up here, and here's the proof. This one we'll do together. So obviously we're going to do the given and CD. Forget my letters, and that's given. Okay, so that's given. X is equal to, second statement, X, we'll call them X to save time, is equal to V. Angle X is equal to V, and the reason is corresponding angles. Reason number 3, Y is equal to W, the same reason. And then Z is equal to V plus W. Z right up here is equal to V plus W. And so that's because of angle, angle addition. It's just the addition property. You can just put addition property. And then finally, the last statement is Z is equal to, what you're trying to prove, is equal to X plus Y, and I wrote W there, X plus Y and again, my writing is not very good right now, but that's okay. You guys can get over it. Oh, no, you know what? It's not the transitive property. I'm sorry. I just looked at my notes here, and let's change that. That's a substitution property. This were just straight substitution. Straight substitution. So it's even easier than I thought. Substitution property. And that concludes the proof for exercise 1. So as we begin looking at these proofs, we remember that construction is going to be a big part of this, using auxiliary lines and then just leaning on things that we've already learned. First of all, for number 1, we identified that the given we identify that the given here once again gives us parallel lines. And so we see that they give us AB is parallel to DC. At the same time, you see that they give us DE is parallel to BC. And so that's important because now we can see a lot of relationships here. Prove that angle ABC and CDE. Angle, prove that, let's go. Angle ABC, this angle right here, is equal to CDE. Prove that. Okay, well, is it necessary? It's not necessarily, not really necessary, but it does help to extend the lines out to see it. Like right away I see it. Right away I see this. So the first thing I'm going to put is, again, get in the habit of doing this. Putting your line, making sure you have the statements here and the reasons. And my first thing I'm always going to put is, well, what's given to us? AB is parallel to CD. And BC is parallel to DE. And that's the reason that's given to us. That's a given. The next thing I'm going to put is something that I know. Well, I know that I'm trying to prove these two angles are equal, but I also know that I know these two are equal. I know angle, and I'm just going to call them ABC. I know angle ABC is congruent to angle, let's see, AC is congruent to angle DCB. DCB. And the reason? Alternate interior angles. Alternate interior angles. And then I also know, moving forward, for the same reason, angle BCD is congruent, angle BCD is congruent to angle EDC. Or you can also label it like this so you don't get confused. You can label this as CDE. So let's go ahead and do that. CDE, which happens to be one of the ones. So that one's there, and then this one's here. And you can kind of see where I'm going with this. Where I'm going with this is, if you haven't seen this, if I just take this off, I take this off, look what happens. These are the same angles. So look at this and look at this and see where I'm going next. I'm going to let you finish that. I'm going to let you finish. The reason here is just alternate interior angles. And you have one more statement to make. I'll let you finish that. And then I'm also going to let you try to finish 2 and 3. Moving forward, finish 1 and then do 2 and 3.